Hello, I'm Professor X today. We're diving into a classic relative motion problem. We'll find the river's speed based on how a boat crosses it along the shortest path. Ready? Let's get started. First, let's list what we know. The boat's speed in still water is 5 km per hour. The river is 1 kilometer wide, and it takes 15 minutes to cross. Since the speeds are in kilometers per hour, let's convert 15 minutes to 0.25 hours immediately. This keeps our units consistent. Got it so far? Our goal is to find the river's velocity. The key phrase here is shortest possible path. This means the boat ends up exactly opposite to its starting point on the other bank. To achieve this, the boat must aim slightly upstream to counteract the river's flow. Take a look at this vector triangle. The boat's actual speed, 5 km per hour, acts as the hypotenuse because the boat is steering at an angle. The river velocity is horizontal, and the resultant velocity, which is the path actually traveled across the river, is perfectly vertical. Notice how the vectors form a right-angled triangle. First, let's calculate the resultant velocity. V net, this is the speed at which the boat actually crosses the river. Since it covers 1 kilometer in 0.25 hours, its velocity must be 4 kilometers per hour. Simple math. Right, this vertical component is what gets the boat to the other side. Now we use the Pythagorean theorem on our vector triangle. The boat's speed squared equals the resultant speed squared plus the river's speed squared. Plugging in our values, we get 5 squared equals 4 squared plus the river speed squared. Now here's the interesting part. We just need to isolate the river's speed. Subtracting 16 from 25 gives us 9. Taking the square root of 9, we find that the velocity of the river water is exactly 3 km per hour. We've successfully used the shortest path condition and basic geometry to solve for the unknown current. If you have any doubts, use the doubt box below for more questions. Ask Professor X.